Wonderful. Well, hello, everyone. Good afternoon. Thanks for staying with us for this conversation about hydrogen. We're going to be looking at how do we green the global supply chain with hydrogen. We'll talk about the different colors of hydrogen. And it's really my pleasure to have this conversation with these two engineers. We have a subsurface engineer, Dr. Scyller Borglum, and we have a surface engineer as well, Abhishek Banerjee. So it's going to be pretty fun. We'll keep it pretty practical, down to the brass tacks of what can we do, maybe a little aspirational conversation as well. So I'll go ahead and introduce myself. I'm Sarah Busch with the Green Hydrogen Coalition. We are a nonprofit that's based here in California. We're focused entirely on building momentum for green hydrogen. And we're focused on building that at commercial scale so it's deployable and usable in the near term. And something we've done within Los Angeles is we've done a study to look at how can we make LA the first green hydrogen hub. And that's really looking at how do you deliver green hydrogen to Los Angeles at a price point that is commercially viable. So we've done a study that shows you can get there. You can deliver green hydrogen to the LA basin at under $2 a kilogram by 2030. And you'll hear that date 2030 coming up because there are a lot of targets that are moving toward that. So pretty timely. So with that, I think I'd like to turn it to both of you to briefly introduce yourselves. Do you want to go first, Abhishek?
Sure. Thank you, Sarah. My name is Abhishek Banerjee. I'm the Hydrogen Commercial Manager for the Renewable Energy Solution business in Shell. I actually started my career in hydrogen, so now I made a full circle and back in hydrogen, so pleased to be here.
Wonderful, thank you. I'm Scyller Borglum, and I'm the underground storage market leader for WSP. We are a worldwide engineering consulting firm, and we are currently contributing to the Magnum project in Utah, which is the largest hydrogen storage project in the continental United States to generate green electricity. So
that is a really exciting project, and Mitsubishi is part of it, and they, as well as the Intermountain Power Project, and they've got some great videos if you want to check that out on YouTube for how they're converting that coal plant to producing green hydrogen. So we're going to talk about the different types of hydrogen today. We'll give you a little orientation to build off of the conversation you likely attended earlier, and then we'll get into different parts of the supply chain. We're going to look a lot at ports, at shipping, and it really couldn't be a more timely time to talk about shipping as we're seeing congestion within our supply chain, and we're seeing increased emissions occurring there while really it is true that ports have been a source of emissions for quite some time. And I was really glad to see there's extra attention, and so glad to CoMotion for having this conversation today, because it's just a really important topic to think about. How can we green our supply chain? And since I used to work in greenwashing, I will say when we say green, we're talking about decarbonization, reducing the carbon intensity, and generally getting, moving towards zero. But we'll say green today, painting a few broad brush strokes. That's totally okay. So with that, I did want to give, get a sense of the folks in the room. It's been a long day, so maybe you want to exercise lifting your arm when I ask this question if you haven't. So we wanted to get a sense of where you're at yourselves with your own hydrogen knowledge. So, and not to put us in a camp of believers and skeptics, but I'm kind of curious to see who in the room is really excited about hydrogen as this new growing market that will be commercially viable, that will be a clean energy solution moving forward. So if you're brave today, raise your hand if you agree it's coming, it's on its way. Okay, cool. That's pretty good. That's about 2/3 or maybe 3/4. And then do we have any, and I say this with love, we have any skeptics in the room? They're a little bit more on the, great, we've got a couple, and we won't, oh, perfect. That's actually my friend right there, is skeptical. So I've got some work cut out for me. It's great to, see, and you're all welcome, and thanks for being brave today and with us. So we'll get into a little bit of hydrogen as a concept. You know, it's the most kind of prevalent element out there. It can be utilized and has been in industrial applications, and largely it's been fossil fuel based to date in terms of how it's produced. And there's been this really big movement and going towards cleaner and greener options for hydrogen. And we really want to keep moving the needle on that. There may be a place for every color of hydrogen, but we want to start bringing that spectrum further over to green. So you'll probably hear about, these different colors of hydrogen. You'll hear gray hydrogen, which is produced with fossil fuels. Sometimes they'll call it brown hydrogen. Then you'll hear of blue hydrogen, which is made with fossil fuels, but with carbon capture technologies. So a really interesting intersection of different markets coming together and different technologies. And then pink hydrogen, which would be made with electricity from nuclear energy, and then green hydrogen, where I focus most of my time, which would be coming from a resource that is, basically zero emissions. So that might be wind, solar, or some type of a closed loop biogas or fuel that's been gasified, or some companies are working on plasmification, which just sounds very, very interesting. And so those different areas of ends of the spectrum, that's what we're going to be looking at today, with mostly looking at green in terms of the supply chain. And we like it because it's very versatile and it can store energy for a long period of time. So there's a lot of potential for helping to decarbonize the energy space, as well as those kind of hard to hit areas like shipping. So we'll talk mostly about shipping today. So with that, Abhishek, I'm going to turn to you to talk a little bit about what you're seeing around the production of hydrogen. And you can go in any direction you like.
Thank you so much, Sarah. First, I just want to thank John and the entire CoMotion team today. I think it's a fantastic event and really pleased to be here today. And speaking about my favorite subject, hydrogen. So I think I just want to start by saying we do produce hydrogen today. In US alone, we produce about approximately 10 million metric tons of hydrogen per year. And it's about 1/7 of the global hydrogen production. So the question is, we are producing hydrogen today. And hydrogen plays a very critical role to meet our needs, societal needs. For example, use hydrogen as a feedstock for refining, and that refining product is used to meet our energy needs today. Hydrogen is used as a feedstock to produce ammonia, and ammonia is used to basically as a fertilizer to keep up with the growing population and food. Ammonia is used to produce methanol, and methanol is basically is used for various applications for household goods. So the question really becomes, how do we produce not just hydrogen, but how do we produce renewable hydrogen? I mean, that is the inflection point. So for a gas that is practically colorless, hydrogen has inherited a lot of different colors. So as Sarah mentioned, in Shell right now, we're looking at various different pathways for hydrogen production. So blue hydrogen, for example, is basically gray hydrogen, where you take a molecule of methane and you combust that with steam. So you react that with steam at high pressure and temperature. And what this does, it basically splits that into hydrogen and off gases. And then you basically purify the hydrogen using a PSA, a pressure swing absorber, and you get a pure hydrogen product. Now, what blue hydrogen does, in the back end, it captures that CO2, and you can use that CO2 for various different end uses. At Shell, for example, I think one of the biggest questions now is, how do we make green hydrogen economical? So to give you a couple of salient projects that we're working on, the first one right now is a project in Germany. It's in the Rhineland refinery, and it's a 10 megawatt PEM electrolyzer. What's novel about this? It's the first at scale electrolyzer, but it also is coupled with the grid. So meaning that, electrolysis offers a sort of a unique advantage where you could do what we call sector coupling. So you're now coupling the power sector with production of clean hydrogen, and that's a novel concept. So that gives you a scale of about 10 megawatts. The next announced project is 200 megawatts. You can see that already in terms of pace and progress is quite tremendous. 200 megawatts coupled with a 750 odd megawatt renewable power plant, offshore wind. So you can see that the pace has been quite tremendous. And lastly, a project that was just announced in North H2 was offshore wind. So it's about a 3 or 4 gigawatt offshore wind project, again, coupled with electrolysis. So what I'm trying, in conclusion, I would say, Sarah, I think the question becomes, how do we make renewable hydrogen competitive? And I think that's a combination of scale. So a minimum viable scale for the project. It has to be coupled with investable policy, meaning that you've got clear policy signals that would basically compete where you've got, where you value the depth of decarbonization and carbon intensity of the product and how it competes with the incumbent, which is gray hydrogen.
Well said. Yeah. Well, Scyller, take us below the surface. Let's go under. Tell me more about storage and transport, how we actually have this vision of kind of this bringing on green hydrogen and then the other types of hydrogen to the market and bringing them to a commercial scale.
Absolutely. So just to make sure we're all on the same page, I'll talk briefly about subsurface storage. I don't know, is anybody in here familiar with subsurface storage in any capacity? Did we, okay, 1, 2, excellent, front row, not surprised. Did you know that we store in the strategic petroleum reserves millions and millions of barrels of crude oil, and those are in salt caverns? So in the Texas Gulf Coast, we have enormous salt domes into which we develop salt caverns. So these are man-made, human-made, and because now I'm here, so human-made. And what you do is drill a well, then you use fresh water, you leach it out. It can take up to 2 years, depending on the size of the cavern that you want. And salt is wonderful as a storage unit because it is a mineral. So if there were any fractures from the drilling process, it actually self-heals because it recrystallizes, and those mineral crystals knit back together. So in Utah, this is an unusual salt dome to have in the center of a craton, in the center of our continent. We have something similar. And to give you an idea just of the size of these caverns, they can be on the order of the Empire State Building. So these are massive caverns, and you don't go into them. The only access point is through a well bore. And this is what makes them such a safe, reliable storage unit, because there's very limited surface access. You don't have problems with weather because they're subsurface. And then you also are able to make sure that they aren't subject to any terrorist or vandalism threats. So these are all important considerations when we look at our infrastructure. You can also store in depleted oil and gas reservoirs. You can store in injection wells, which are deep into the earth in saline formations, or you can store in hard rock caverns. But for the most part today, we're going to talk about salt caverns. And you can store hydrogen there. You would store, just if there are any other engineering types in the audience, you can store your hydrogen at about the same pressure and temperature specifications as you would your natural gas, but you need about 3 times as much hydrogen volumetrically as you do natural gas to equal the energy density. So does that help?
Yeah, really interesting. Can you talk a little bit about pipeline storage as well?
So pipelines are one of the missing links right now in our hydrogen economy, given the volumes that we are looking at for utility scale usage of hydrogen. And I expect in many ways, that's where we're going to want to go. We need pipelines. We need pipelines connecting the production location to the storage location to the use location. When you have highly dense areas like Los Angeles, you aren't likely going to have a large scale hydrogen production facility right next to where you are going to want to use it. So if your point of use is far from your production and your storage, right? And you're going to want storage because you need to create some slack in the system. We learned in COVID times that just-in-time inventory didn't work in the grocery stores, and it didn't necessarily work with our fuel supply. So we need to have some slack in the system, and that's where the storage comes in. So you want your production location, you want your storage location, and then your point of use location, but those will generally need to be connected by pipeline because the volumes we're talking about are simply not feasibly going to be transported via rail or truck. Those are going to invite additional emissions issues. So
Yes, it's such an important preface for talking about decarbonizing shipping with hydrogen is how do we actually get it there? So thank you for that. And thank you for mentioning safety. We won't have time to get into it, but we could talk about it offline. There's so much potential for this to move forward and for industry to scale, like you're saying, and do it safely. What are a few of the barriers, just so folks realize there's a lot of work that still needs to happen. These great folks are working on it. What are you focused on most lately in a few words, and then we'll switch to looking at a specific supply chain. So you want to go first?
Sure, Sarah. I think the way I think about it is widespread adoption of hydrogen in two sort of areas. One would be how do we displace existing gray hydrogen with renewable hydrogen? I think that's the first topic in mind. And then I would say, how do we have widespread adoption for emerging industries, so mobility and hydrogen for home heating, for example. So existing sectors and then emerging sectors are the two sort of two-pronged approach. I would say the first thing we would have to focus on is clear targets, clear policy signals and targets with a time horizon on it. So it gives a clear market signal. I would say it should be an investable policy, meaning that the depth of decarbonization and the carbon intensity of the production pathway is valued. I would say it has to focus on market fundamentals because we see hydrogen as an energy vector, meaning that it can be stored, it can be transported, it's very resilient. So and it might be quite regional as well. So I think we're quite agnostic to the pathway, but really focusing on market fundamentals is going to be quite important. This is an overused sort of phrase, but the chicken and the egg is true. So really, what comes first, infrastructure or production? I think that has to be coordinated and it has to be sequenced as well. So I think that's a really key element. And last, but really important, customer adoption. So we are a customer-centric organization at Shell. We do offer a mosaic of different solutions in the renewable energy solution space. So we're looking at biofuels, renewable natural gas. We're looking at EV charging. So I think the jury is still out as to where hydrogen is going to play the most critical role, but we do see hydrogen will play a role, and it's a matter of being very deliberate and purposeful where we choose, we use that end molecule. So.
Anything to add over there, Scyller?
I'll add one point. So as a recovering politician, I think one of the places that we need to really take a good look at for barriers is currently a lack of dependable, reliable regulatory framework. What do I mean by that? We don't, in any other transport setting via pipeline or storage, we have the regulatory framework that we use for natural gas, or that we use for propane, or that we use for crude oil. We have that in place. So companies like mine, engineering consulting firms, can go in, we can start the permitting process, we can help companies interested in doing this work move it forward. In a total absence of that framework, we can take a good guess. We can use the natural gas rules and regs, or we could use CO2 sour gas rules and regs, but we don't have anything specific to hydrogen. So in addition to everything that my colleague lined up, I would also humbly suggest that state and local governments who do most of this for themselves, and then of course we need the interstate rules as well, put these in place. And you can use CO2 sequestration, you can use natural gas as your guiding principles, but big companies aren't going to want to make a massive infrastructure investment in spite of all the incentives they're given if they're not sure exactly what the rules are that they should be playing with, because nobody wants to get a pipeline halfway built only to have it rejected.
Well, that's a nice segue into something I was going to introduce as we talk about shipping and ports. So looking at one piece of the supply chain, because there are so many that can be decarbonized with hydrogen. We want to talk about shipping today. And we're not too far away from two of the largest ports, the Port of Long Beach and Port of LA, that serve this area and actually account for 40% of the imports from abroad that come into the United States. I mean, that's substantial. And, speaking of local regulatory action, the LA City Council earlier this month adopted a resolution called Ship It to Zero, which is calling on all of the major importers to achieve zero emission shipping by 2030. And this is largely an effort through local action and activists. And I shout out to Pacific Environment. Definitely recommend looking them up. They have a great report that illustrated that on an annual basis, about 1 billion metric tons of greenhouse gas emissions are attributed to shipping, global shipping. And when we have about 40 to 50 billion metric tons emitted each year globally, that's a pretty big chunk that we can decarbonize with hydrogen. And really great to see that LA is taking this action and calling on those large corporations to go ahead and convert their supply chains. So they have an interesting challenge ahead of them. And these folks are here to help. And I think we're going to learn about some projects that Shell's doing to help decarbonize the Port of Long Beach in LA. But Scyller, I wanted to turn back to you and say, how is hydrogen going to help ports, which are largely fossil, relying mostly on fossil fuel sources, to my understanding. And really, there's this big opportunity. Do you want to opine for a moment on the local air pollution emissions are quite severe. So there's this great opportunity to help with public health as well.
Absolutely. So as Sarah mentioned, we have emissions on the order of 2 to 3% come from the shipping industry. And even though there's been a portion who have converted to liquefied natural gas, there's still, I think that's on the order, write this in pencil, don't write it in Sharpie, but I think it's about 20% that have done that. Still a considerable amount use fuel oil. And when you're in port, there are a number of considerations. Number one, depending on which way the wind is blowing, you could have the emissions from the stack blowing in the face of the crane operator. Well, if that's the case, and these are just practical rubber hits the road kinds of problems. If that's the case, then they either have to move the ship, or they have to wait, or they have to adjust how they're offloading the ship. Well, that takes time, and ships don't make money sitting in port, right? They make money when they're out doing their business. So we want a fast turnover, but we also recognize that there are health and safety issues of the people who work in the ports. In terms of the practical application, there are just simply components to consider. How are you going to get the hydrogen there? Is it with pipeline? You refuel ships from the water side, not from the port side. So that would need to be solved for. You need compressors. You have to redesign the ships in some capacity. So none of these problems are insurmountable. None are insurmountable. But they will take the due diligence of talking to people within 20 feet of the problem to come up with an adequate solution. And I will add one, in Norway, they have made the decision that by 2030, all of their shipping industry needs to be emissions free, and that'll keep the emissions out of their fjords. So they are already committed to their hydrogen efforts. So these are exciting times that we're living in for the shipping industry.
And any other of those adjustments are very interesting. We'll have to change how our ships are made. And then I've heard about the queuing process may need to shift. And you shared a little bit about refueling and how that may need to shift. Any other practical shifts that you see needing to occur? I think those are the primary ones. And really it'll come down to how can we turn over the fleet that is in existence? It isn't that these ships, many of them will be able to be retrofitted. And so we are looking at a turnover of these ships, because they will, like our vehicles, need to be redesigned completely. An example would be right now in their shipping fuel, they use those to help ballast the ships. So if you totally change the mechanism by which a ship is powered, then that's something that has to be reconsidered. So again, none of these problems are insurmountable, and they're being worked on as we speak, but it's rubber hits the road kinds of issues to consider. Yeah, we're going to get practical in this session. So can I pass it to you, Abhishek, about, I'd love to hear more about your projects and, what you guys are doing in the ports around right now around decarbonization. And then I had a follow-up question for you about what else would you like to see? What more could we do? And if Scyller, you have anything to add there too around decarbonizing the ports, your dream project at a port, that would be cool to hear too.
Thanks, Sarah. I'll try to keep it quick in just time. But one of the projects that we've just launched this year. It's called Project Zanzav. So it's basically zero emission and near zero emission freight projects. And this is a really prime example of public-private partnership, almost a blueprint where it really shows you how you can sort of overcome some of these concomitant challenges of starting a project. We know what comes first, infrastructure versus production. So I've got this paper here because I don't want to forget anyone, but this is a really, I just want to give a recognition to the consortium that led up to this project, which is basically Port of LA, Port of Long Beach, Toyota Motors North America, Toyota Logistics Services, Kenworth, the fleets, basically the fleet operators, which is TTSI, SCE, UPS, the equipment providers, Nell, and CARB and the CEC. So you can clearly see that it's a lot of different stakeholders coming together to put this together. So the real objective of this project, I would just summarize by saying, is threefold. First, relaunch, if you will, the freight market for zero emission transportation. So using hydrogen as a fuel. This was in consortium with Kenworth, basically building the chassis, and Toyota providing the fuel cell train. So essentially it's a heavy duty fuel cell electric vehicle, uses hydrogen, pure hydrogen as a fuel to propel with basically zero emissions. So the use case for this project is really apt for hydrogen because the duty cycles are really fit, if you will, for hydrogen. You're using heavy trucks with heavy payloads, and that's where we see a unique advantage for hydrogen because of the batteries would roughly take about 25% of that payload. So a really good example of a use case for hydrogen. I would say, I think we already talked about this, but the local air quality emissions. So right now in the ports of LA, there's about 16,000 trucks. And it's probably one of the most congested areas, if you will, it's one of the largest trade corridors with a lot of shipping containers. So I think this project roughly would abate about 500 tons of CO2. But what's really important is also not just the CO2, but the particulate matter as well that comes from combusting diesel. And lastly, I would say a good example of refueling infrastructure at scale. So Shell, we've just built 3 heavy-duty refueling infrastructure. Basically, what this shows, it's about 1,700 kilograms a day, roughly about 3 times the capacity of our existing stations. So just want to elaborate that a consortium of this type can really enable that scale and at a commercial level. So,
yeah, I love to see that collaboration across industry, public sector, visionaries, funding, more of that. That's what I want to see. If I could just inject my own dream project. Do you have, you guys are doing a lot. Where would you like to take it next if you could have your dream project at the ports?
Absolutely, Sarah. I think the ports will play a critical role. I think it'll be a real cornerstone of the hydrogen strategy as well. And the reason I say that is when we think of hydrogen right now, one of the predominant challenges, and I think we spoke about this, is how does hydrogen become competitive? So when we think of that, one of the ways that you could mitigate that is by having anchor customers. So, across the ports, if you have got industrial clusters, you could set up co-located hydrogen production. You could sort of rebuild that demand, and the ports would be sort of a segue for import, export, and I would say the hydrogen as a hub concept will really take off at the ports, and that with those economies of scale, then you can really have a solution which is competitive, which is resilient. And we talk about supply chain as well. I think that's one sort of vision where you could sort of connect the clusters, the industrial clusters, along with ports. And one of the elegant, solutions for hydrogen is the fact that you can couple demand segments with complementary demand profiles. So you could have a production asset which is serving an industry or a refinery, and then you could have flex volumes that could actually be used to decarbonize transportation. So I think that's where this concept that hydrogen as a hub could really take off at the ports.
Yeah, multi-sector solutions. Scyller, if you want to answer the question too about dream projects, what would you like to do around hydrogen? What are you most excited about?
Developing more salt caverns.
Nice. Excellent. I love learning about this really interesting part of our geology and the way we've utilized it. And so, you know, around ground transportation, did you have any more you wanted to add around that? And then we could go to our kind of lightning round. And then if there's time for questions, we could take a few from the audience.
Absolutely.
But you know, decarbonizing the ground transportation part of our supply chain, I mean.
Sure, sorry. I promised to keep it succinct, but I didn't. So I think what we see for ground transportation, I'll just start from the light duty and the passenger vehicle space. We've seen a tremendous pace and progress. So if I just go back to 2012, you know, our stations were designed for about 200 kilograms a day capacity. In 2017, we've sort of doubled that and half the cost. And in 2022, we predict further, you know, doubling the capacity again and decreasing the cost by 50%. I think a lot of this is possible because now we're seeing that inflection point in hydrogen mobility, where it's keeping up now. We can see that, you know, the pace of progress and the learnings are seeping in. So a real good proof point right now in California, we've got about 9,000 fuel cell electric vehicles. Last year, you know, the Shell portfolio, we actually dispensed 100% renewable hydrogen. So you can see an inflection point where, you know, you're decarbonizing the supply chain. There are more stations, you know, products, technologies rather are turning into products. You're seeing policies which are basically turning into markets. So it's really a market-based mechanism. And I would say we're pretty encouraged to see the, you know, the customer adoption. You know, you could call it at its infancy, but we're seeing some good momentum in the light duty space as well.
Yeah, thank you. So on to our lightning round, because I feel like we're on a podcast. Scyller, if I had to put you on the spot, in what year do you think hydrogen is going to reach commercial kind of scale viability in the market broadly?
I would put my number more on 2040. I think if we were about 20 years out, I think that'll be about right.
Love it.
I would concur with Scyller on that as well. I think if we continue to have the shared objective, I think we could get there in, you know, a decade or two. Yeah.
Mm-hmm. Yeah, I'm hoping for 2030 here in LA, and then sky's the limit. And if you had a magic wand and you could just transition any part of the supply chain today, I'll go to you still again, Scyller. What part would that be? And I mean, you can answer hydrogen powered drone if you want, or something fun like that. But, you know, really just any piece that you'd really like to see transitioned right away.
Well, I am intrigued by the hydrogen powered drone, but last night we had the opportunity to sit in the prototype for the taxi and the air taxi, which was really exciting. And as somebody who is also a sci-fi nerd, that would be really at the top of my list. If we had hydrogen fuel cell air taxis that just picked you up and took you to your next location. So that's what I would go for.
Isn't the DeLorean hydrogen powered? I can't remember. And for you?
I would say, I think we have to work the entire supply chain, but immediately I would think production, renewable production of hydrogen and efficient distribution of hydrogen, whether it's pipelines or, you know, the midstream distribution trailers, I would say are quite critical to set up the hydrogen economy.
Mm-hmm. Yeah, get it out there, you know, to consumption. And then if you were, you know, thinking about the future, this green hydrogen or mostly low carbon hydrogen powered future, how do you guys feel? Like is in one word, how are you feeling? Go to you, Scyller.
Like we did good work.
Yeah.
Yeah.
Great.
I would say I feel optimistic and encouraged. And I think if we continue to share the common objective of decarbonization as a society, I think hydrogen will play a role. And I am, as I said, I'm cautiously optimistic, but I'm optimistic.
Yeah, we're just building the momentum now, really, with everyone in this room and with you guys. So thank you so much. We're, you know, 15 seconds off of our time. So I think we'll go ahead and wrap up and appreciate everyone's attention while we had this conversation. Thank you.